Hi, I'm Tailin, a PhD student from Newcastle University. In this video, I'm presenting our work, titled, Part-Aware Prototypical Graph Network, for One-Shot Skeleton-Based Action Recognition. This work done when I was a research intern at Baidu department, and also a visiting student at ShanghaiTech University. Our presentation will begin with an introduction to provide context and background information. We will then move on to the methodology section, where we will describe the main idea and techniques we used in our research. Next, we will present the experiments we conducted and the results we obtained. Finally, we will conclude by summarizing our work, and providing a link to our code for others to access and potentially build upon. Action recognition is an important task in human-centered scene understanding, and has achieved much progress in computer vision and multimedia. As shown in this picture, different from learning directly from RGB inputs, skeleton-based action recognition use inexpensive motion sensors, or effective pose estimation algorithms to extract human skeleton sequences for recognition. The skeleton data typically are more compact and robust to environment conditions than its video counterpart. However, existing fully supervised skeleton-based action recognition methods typically focus on the problem of many-shot classification, where each class has substantial number of samples during training. Nevertheless, the acquisition of well-annotated skeletal sequences is labor-intensive and time-consuming. Therefore, one-shot skeleton-based action recognition is developed and aims to classify novel human actions from skeleton sequences with only one labeled sample. As shown in this picture, in fully supervised learning, the class information of test sample is known during training, while the class is normally unknown in one-shot learning. There are two challenges need to be considered in this task. The first challenge is to learn transferable representation from base classes to novel classes. The second challenge is to effectively recognize fine-grained actions. For example, action typing on a keyboard and writing, only two hands are involved. Analyzing such subtle motion patterns can be helpful in recognition. Recently, graph convolutional networks, such as STGCN, have been largely adopted in skeleton-based action recognition. MatchingNet and ProtoNet provide a promising one- or few-shot learning strategy to learn transferable knowledge. Yet, they are rarely investigated in this one-shot skeleton task. Existing one-shot skeleton-based action recognition excessively rely on learning a holistic representation. Although, such a strategy may have the capacity to perform well on most action classes, due to the high model complexity and limited training data, they often suffer from inaccurate predictions on fine-grained action classes. For example, recognizing action hand waving is much easier than that of apply cream on face, as the latter action needs more fine-grained information. So, our idea is to explicitly modeling the part-aware prototypes using meta-learning strategy. Besides, we also develop a class-agnostic attention mechanism for part prototypes fusion before final classification. Comparing with baseline methods, our model performs much better on some fine-grained action classes. Next, we will introduce the details of our model. Basically, as shown in this picture, we constructed our framework with three modules. Given a skeleton sequence, the cascaded embedding module first transforms this raw sequence into multiple part-based representations. Then attentional part fusion module will highlight the important parts and generate part-aware prototypes. Finally, matching module will calculate the distance of different prototypes using cosine distance metric. Specifically, in cascaded embedding module, there are three steps. First, we employ a basic graph embedding network to generate a context-aware feature, which referred as body-level modeling. Second, we construct different part-level graphs according to the rules. Third, we use a non-local graph network for part graph modeling. The attentional part fusion module is designed to highlight part representations, and generate the final part-aware prototypes. The part representations are first concatenated to form a unified representation, followed by a semantic attention module to produce the importance values. The values are then multiplied to the original part representations to form the output part-aware prototype. Finally, the matching module calculate the cosine distance between generated prototypes. In the inference process, a query sample is classified by assigning the class of the nearest support sample using this distance function. On two public datasets, NTU RGB D120 and NWUCLA, we follow the standard evaluation protocol to evaluate our method. Top 1 accuracy are reported under different setups. Here are the performance comparison with current SOTA methods. Our proposed part-aware proto-network consistently outperforms existing methods under all evaluation setups. Our experiments also suggest that, directly adopting advanced GCNs in many-shot setting, cannot bring better generalization in this one-shot setting, where the key is to learn novel action classes given knowledge from known base classes. Furthermore, to verify the effectiveness of our modules, we first evaluate the proposed part-level modeling and attentional part fusion mechanism in an incremental manner. We start from our baseline network, body-level STGCN. We then add our proposed modules one by one. The results are shown in Table 1. We can see that our part-level modeling and attentional part fusion module have consistent improvement, which demonstrates the effectiveness of such divide-and-conquer structure. Note that, in comparison with the baseline model, our novel part proto-network model only incurs a 1/3 increment in the number of parameters, yet yields a significant performance boost. As we generate multiple part graphs based on the natural topology of human skeleton structure according to the rules, we compare different numbers of generated parts. Results are shown in Table 2. The performance of the model varies with the graph number k. The accuracy gradually improves. When k equals 10, it reaches the best performance and subsequently drops. This is because that too many part graphs contain redundancy, and our attentional fusion module cannot generate informative prototypes from the noisy part representations. Our part-aware proto-net provides a good trade-off between model complexity and performance. In our part-level embedding network, we adopt a non-local style message passing regime to capture spatial joints correlations. We thus exploit the effect of different self-attention heads and report the performance. Interestingly, a single head self-attention is enough for part modeling, as our part GNNs only model patterns at a small region. And, also, we explore the different fusion strategies. The MLP-like attention achieve the best performance in our framework. Here we present some visualizations. In this figure, we visualize the attention prediction of attentional part fusion module. For each skeleton, we show the top 3 important part graphs. We can observe that, for different actions, our attention block can select different information parts, while for the same action, attention is similar. This demonstrates that our attention mechanism is class agnostic. The learned graphs can help in one-shot recognition. In this figure, we compare our model with baseline holistic modeling method. On 8 novel fine-grained actions, which highly rely on hands, we can observe that our method outperforms the baseline STGCN on each class, demonstrating the effectiveness of our local part-level modeling. Here's a summary. We propose a novel part-aware prototypical graph network for one-shot skeleton-based action recognition, which can help in learning rich fine-grained transferable representations. And we achieve the SOTA performance on 2 public datasets with the help of learned prototypes. Our code and models are also available. Thanks.